All right, welcome back, Hononegah, Algebra 1, Section 5-6. So we're going to talk about graphing lines, but we're graphing two variables now that have an inequality symbol. And so there's a little bit here that we're going to need to talk about. A linear inequality with two variables, x and y, can be written as a less than or equal to, a greater than, or greater than or equal to. The a, the b, and the c are all going to be real numbers, and the solution is the two variables in which the ordered pair makes the inequality true. And so we're going to talk a little bit about how we're going to decide whether or not it makes it true. So if I give you an inequality like 2x plus y is less than -3, so this one down here, and I'm going to put -1 in for x and 9 in for y. So -1 in for x and 9 in for y. And I'm going to decide yes or no if it's true or not. And you do need to show your work. Just don't put true or false or yes or no. You actually need to show me why you decided that. So -2 plus 9 is 7. And is 7 less than -9? And the answer to that question is no. Okay, it is not true. And if you want to, you can also cross that off because 7 is not less than -9. Next one, I'm going to put 2 in for x and -2 in for y and decide whether or not it's true again. So is 2 plus 6 greater than or equal to 8? Is 8 greater than or equal to 8? And the answer to that is yes, it is true. So that is one way to decide where you're going to shade. So here's what we're going to do. We're going to graph the boundary line. So we're going to graph just the line. And then we're going to have to deal with what's called dashed or solid lines, depending. So if you have a greater than or a less than, these will all be dashed. And if you have a greater than or equal to or a less than or equal to, these will all be solid. So the equal to line tells whether or not it's going to be a solid or dashed line. And then you are always going to shade half of the graph. So you're either going to shade above or below or to the right or to the left of the line. So again, you're always going to shade half of the graph if you have one inequality. So these are the steps. First, you're going to graph the boundary line, then decide whether it's dashed or solid. You're going to test a point. Now, this one right here, I'm going to put a bunch of stars by that. You can test a point, and I will help you with testing a point, but decide. Basically, don't pick a point that's on the boundary line, but you can also decide this by less than kind of being below and greater than above. So I'm going to give you a little bit of a shortcut as we do this as well. All right, here we go. Y is less than or equal to 2. So if I drew a line for y equals 2, and it's straight across, and then you have to decide where it's going to be shaded. So where are the y values less than 2? And I'm going to be honest with you. Anytime you have a less than or equal to, you're really going to shade below the graph. So think about that. All the points below the line in this case. So like, let's say I picked the point 3, -1. If you put -1 in for y, would it be true? And the answer to that is yes. So everything that's below the line would be shaded. So the next one, x is greater than 5. So we got a dashed line at 5 and shading. So where would the x values be bigger than 5? Well, if I picked a point over here like 8, 2. If I put 8 in for x and 2 in for y, and there's no y, so just 8 in for x, would it be true? And the answer to that is yes. So all the points on that side would work. All right, so now this gets us into a little bit more. All right, first of all, think of this as just an equals. So forget about the inequality symbol for a second. Add x and divide everything through by 2. So I get 1/2 x plus 1. So this goes back to chapter 3 when we did graphing lines. So 1 is the y, 0, 1 is the y-intercept with a slope of a half. So up 1 over 2, up 1 over 2. Now let's decide dashed or solid. So now I'm going to go back to the original question and I see a greater than symbol. So I know that this will be a dashed line and now shading. So it's going to be either above or below. So you're either going to shade this graph above the line or you're going to shade this graph below the line. So here we go. How do I decide that? Pick any point you want that's not on the line. For instance, if I picked like 0, 0, which is right here, below the line. If you put 0 in for x and 0 in for y, is it true or not? So is 0 greater than 2? And the answer to that is no. So if it's not true below the line, it is true above the line. And remember, this being greater than is also a hint as well. All right. First, set it equal and solve for y. So x plus y equals -4. Solve for y. So I got a y-intercept at -4 with a slope of -1. So it goes down 1 to the right 1. It's an equal to. So it's solid. So this is what I'm looking at right here. It's an equal to inequality. Now test a point. And again, let's test 0, 0 one more time. Is 0 plus 0 less than or equal to -4? And the answer to that question is no, it is not. And since that point is not true, then every point on that side is not true, which means the other side is true. On your own, try each one of these. Hit pause. All right, welcome back. So we're going to put -2 in for x, 2 in for y, and decide if it's true. And the answer to this is no, it is not, because 0 is not greater than 0. Put 0 in for x and 0 in for y and decide if it's true. And again, it is no, it is not true again. 0 is not greater than or equal to 5. Graphing. So x equals -4 is a vertical line. It's solid because there's an equal to in the problem. And less than would be shaded to the left of it. The next one, a little bit harder. So -2y equals -x. I'm going to solve this for, so I got a half x. So 0, 0 with a positive half. And here's where things get a little bit confusing. It's dashed. But now where do I shade this? Again, pick any point you want that's not on the line. For instance, this is the point 6, 0. So if 6 for x and 0 for y is not true. So every point on that side of the line would not be true, and only the points then on the other side of the line would be true. Word problems now. You can spend at most $10 on grapes and apples for a fruit salad. Grapes cost $2.50 x. Apples cost $1y, and you get $10, and you need less than or equal to $10. So solving this for y. So it's got a y-intercept at 10 and a slope of, now I'm going to turn this into a fraction instead of a decimal, so that's -5/2. So it goes down 5 to the right 2 and down 5 to the right 2. It's a solid line, and it's shaded below or shaded to the inside here. So the x was my grapes, and the y was my apples. And we're talking about a fruit salad. So now identify and interpret the two solutions. So basically what they want is give me two answers that are in the shaded region. Any two answers. So like 2, 2. So if you buy 2 pounds of grapes and 2 pounds of apples, then you have enough money to pay for 2 pounds of grapes and 2 pounds of apples. Another example, let's go 1, 6. So 1 pound grapes and 6 pounds of apples, and you would have enough money to pay for that as well. So homework assignment for this section, make sure you check with your teacher about what your homework assignment will be. I believe the assignment is on page 271, 3 to 37 odd, and number 40. If you have any questions, make sure you talk to your teacher, and good luck.